So in previous videos, we've talked about how to run various programs on DOS, but how do you create your own FreeDOS program? So that's probably the number one question I've gotten so far is how do I create a FreeDOS program? So that's what I want to do today. Just do a couple of simple FreeDOS utilities using the OpenWatcom C Compiler. So let's get started. So you can actually use different programming languages to create programs for FreeDOS. We include a number of programming languages with the FreeDOS 1.2 distribution, including, as I mentioned, the OpenWatcom C Compiler. There's also assembly, BASIC, Pascal, other different programming languages. But as I said, I like to use C, so that we're using the OpenWatcom C Compiler today. Now, I've already installed that using the FD-Impulse tool, and that's covered in another video. But if I do a dir, you can see that I've got a devel directory, and that's where OpenWatcom got installed. So let's go ahead into the devel directory, and you can see the OpenWatcom directory there. So let's go into OW. And you can see all the different directories that are part of the OpenWatcom C Compiler. There's also a batch file in here called owsetEnv.bat, and that is going to set my environment variables for the OpenWatcom compiler. If I just type that out, owsetEnv, you can see here it's setting the path, the location to the include directory, the Watcom base directory, and other directories for OpenWatcom. And I could have put this in my autoexec.bat so that way the variables are there all the time. But for this demo, I just wanted you to see what variables you need to have to make OpenWatcom work. So now that I've got that, let's actually run owsetEnv to actually set up my environment. And now let's back up one directory and create a directory just for us to work in. So let's go ahead and make dir source, src, go into src, and let's just create just a simple hello world type program. I'm going to use the FreeDOS editor for this. So edit hello.c. Very simple program here. There's not much to it, so we're going to just start by doing a include on the standard IO functions. That's the header file for that. And that does includes various functions that let you print to the screen or read input. It's the standard I/O input/output. And I'm also going to use the exit function, which is defined in the standard library. So include standard lib.h. And now my main function, int main. And I'm not going to process any command line options, so we'll just do void on this one. And void just means no options. Now, it's just a simple hello world program. So let's go ahead and just write the string hello world. So we're going to put a string on the screen that just says hello world. And immediately then exits back to DOS with the error code of 0, which usually indicates success. And then let's go ahead and save that file and exit. And now to compile that, you're going to use the Watcom C compiler and linker. And there's hello.c. And you can see it compiling the hello program. It's going to go ahead and now link that program. And it's now created a DOS executable. So I do a dir, and you can see hello.exe as well as the log file for the error. And there's the object file, which is the intermediate file between compiling a C program and creating the executable. So if I just type hello, you can see that it just prints hello world. Pretty simple program, very easy program. When I created the FreeDOS to begin with back in 1994, I actually just opened up my DOS reference and started writing versions of programs based on the MS-DOS user manual. A very simple program is the echo command. So let's go ahead and create a very simple version of the echo command. I don't want the compiled name to be confused with the internal command for echo, so we'll just call this one necho, or the new echo command. And this is a very simple program. So again, we're going to include the standard I/O, And we're going to call an exit function later, so let's go ahead and do an include on the standard library. We're going to do an int for the main function, and there's the main function. And I am going to process a command line in this one, so let's go ahead and do an int argc and character argv. So what is that doing? That star star is really anytime you do a star on a variable like that, you're saying that's a pointer to something. I think if you're going to look up pointers, probably best to go ahead and read a book or follow a course on that one. I don't think I'm going to be able to explain that here if you haven't done C before. But the star star means this is a list of pointers. So a pointer is, in this case, a pointer to a string, and then it's a list of pointers because I have multiple options on the command line. So let's go ahead and write a simple function to do an echo type command. So in this case, I'll just need to iterate through my command line. So for that, I'm going to need a variable that will let me iterate. So I'm going to do int I. Very bad programming style to just have single letter variables, but this is a simple program, so I think I can get away with it. So let's go ahead and process my command line. For I equals 1, so we're going to start at the first option. Now normally variables arrays start at 0, but 0 would be the name of the program, so we need to start at 1. I is less than argc, and we're going to increment the variable every time we go through this loop. Oops, there's my for block. And it's we're just going to print a version of that string here. There's the string that we're going to find in the command line, every option. We'll just put a space after it. Notice I'm not putting in a new line, and then it's going to be argv I. And so what is that? That's saying that's the as I count through this, options 1, 2, 3, 4, it's going to just print each one of those command line options with a space after it. And we're going to glue them together on one line. And then when I'm done with the for loop, I'm going to need to print out a new line. So I'm going to go ahead and do a put char on a single character, and then I'm going to use single quotes for that. \n is a new line. And then that's it. That's an easy little program. So we're going to go ahead and exit back with an error level of 0, indicating success. So let's go ahead and save that and exit. And we'll do a compile that and echo.c. So there it goes, compiles echo.c. And now it's going to go ahead and link it. And there we go. So n echo hello world, and that prints out hello world. That's a very simple program just to create a simple replacement to the DOS echo command. That was actually one of the first programs that I wrote just to look at what that looks like. N echo.c, right? That was a very simple program. Let's do something a little more complicated as another example, and that is another version of the type command. So let's go ahead and do edit, and we're going to start ntype. This is a new type command, so I'm just going to call it ntype.c. So again, I'm going to include my standard I/O functions. I'm going to include the standard library because I'm going to call an exit function later. And let's go ahead and get started. So we're going to do, might as well start by defining our main function, int argc char argv, right? And that's my my main function. So what am I going to do for this? So this is going to display the contents of files. So what I need to do first here is to process the command lines, the command line options, which should be lists of files. So I'm going to need something that will iterate through my command line. So int I. And I want to keep track of the error level code. So I'm going to actually create another integer called exit code. Oops, exit code. And I'm going to be opening some files here, so I'll need a file pointer for that. So there's a file. We'll just call it p file, right? It's the pointer to a file. Now, let's scan the command line. And we're going to print the file contents. So let's do a simple for loop. Let's go ahead and process the command line. For I equals 1, we're going to start at the first command line option. And then I is less than argv, or argc. And then we're going to increment I as we go through the loop. Now let's go ahead and open each file as we go. So we're going to do a pointer to the file is fopen. And what file am I going to open? Well, I'm going to open up argvi. So that's as I go through the command line, I'm going to look at the first file, the second file, the third file. So I'm opening up each file as I go along. Fopen argvi, and we're going to open that for reading. Now, if fopen succeeded, then it's going to give me a pointer to the file that I can then use. If it failed, usually because the file wasn't there, it's going to return a null. So I need to do a test for that. So we're going to say if p file is not a null pointer, then I'm going to do some stuff. So I'm going to use a function called, let's call it show file, because it'll show the contents of the file, and we'll just pass it the file pointer. We'll let it deal with the reading of the file and printing it to the screen. I'm assuming that worked out okay, so we'll go ahead and set the exit code to be 0, which would indicate success. If this is the only file we've opened, or at least is the last file we've opened, it's going to exit with an exit code of 0 to indicate it succeeded. Now, if it didn't open up a file, and actually, now that we're done with that, let's go ahead and, since we've opened up a file, and now that we're done with it, let's do fclose, right? Let's finish that file, p file. Right, so now I've opened the file, I've passed it to the show file function, and then I've closed the file pointer. Now, if our fopen did not work, it would have returned a null value. So we want to look at else, and in that case, we'll just print out an error message. So we're going to do a it's like a printf, but we're going to print to a specific file stream, so fprintf in this case. And we're going to print to the standard error file stream, standard place where you'd write error messages. And we're going to give it the message could not open file, and we'll tell it that was the file that we couldn't read, and a new line. And then we'll tell it what file we couldn't read. It was argvi, right? We couldn't open that file. And because if this is our last file that we tried to open, then I want to be able to pass that back as an exit code. So we'll set the exit code in this case to 1. That'll indicate we had some failure at the end. Once we're done processing all of our files, this is the end of the for loop, by the way. So that's our for loop. Once we're done with that, we're going to want to go ahead and return to DOS and give it the exit code. Now, I've missed something here. If there's only if I'm not giving it any command line options, if I'm not telling it any files, then that for loop is going to just immediately exit. It's not actually going to process anything. So I'll actually need to be able to deal with that. So if argv or argc was 1, then let's just do a show file on the standard in, right? That's the standard input, and then we'll just indicate that the exit code, in that case, oops, succeeded. So exit code is 0. And that should deal with my case there. So now I need to create a function called showFile. Let's go ahead and save my work as long as I'm at it. So go ahead and save. And let's go ahead and create the function called showFile. I'm going to go ahead and put this up at the top. So that way the main is the last function being called here. That way I don't have to do I can get away with not having to do a primitive. So let's go ahead and write the function. There's a couple of different ways you can write this kind of a function. First of all, let me go ahead and set up the function. Void showFile, and I asked it to send a pointer to a file. So there's my showFile file p file. There's a couple of different ways you can write this function. The simplest way, and then I'll show you the better way to do it. The simplest way is to just use the standard C functions to read from a stream, and we're going to read one character at a time because there's a function to do that, and we'll just print them out one character at a time because there's a function to do that. So to do that, I'm going to need to have a variable to capture the characters as I read them, which it turns out is an integer. And let's just do it as a integer ch. That's my variable. And I do this as a while. So let's say while, and there's my while loop. Now I'm going to need to open up or read each character from the file as I go, and I like to do that as part of an interior function inside my parentheses. So I'm going to say while I'm going to first read in ch is the value of fgetC. Right, that's going to get a single character from a file, and that file is p file, right? And so it's going to actually execute this command, and then it's going to return the value of that because I wrapped it in parentheses. And I can now use that to compare, and I'll say as long as it's not the end of file, which is what you would happen when you reach the end of the file, then it's going to do this loop. And as it does the loop, I need to now do something with that character. All I'm doing is showing the contents of a file. So in that case, I can just immediately print that character to the screen, and that's putchar, right? ch. And that's all it is. This is a very simple version of the type command. So let's go ahead and save what I've got. And let's go ahead and compile it. So now I've got that saved, we'll exit, and we'll do compile using WCL and type.c. Let's see if I made any errors. There it is, compiling it. And it is linking it, and there we go. So if I do a dir, you can see that I've got a simple, I've got an ntype .c, I've got an ntype.error, which is the error log, and I've got the ntype.exe, which is the compiled binary, and then ntype.obj, which is the, as I said, the intermediate step between compiling a C file into an executable. Now, if let's go ahead and create a test file just so we can see what we're looking at. So we'll just create a file called test.txt, and I'm just going to write a simple line here that just says this is a line of text and the end. So that's just a simple test file. It's always good if you're going to write a program to have a test file that you can work against to make sure you know what it's actually doing. This way I don't have to actually be typing out a source file. This way I know what the file should look like. So if I do ntype, that's my new type command, and tell it test.txt, I should see the output of the file, and there it is. And that's exactly the same as the FreeDOS internal command, type test.txt. Right? You can see it's exactly the same command. Now, there's a different way that you could write this program. As I mentioned, there's two different ways you can really write this. That's the easy way to do it. So let's go ahead and look at that file, ntype.c. Now, every time you call fgetC, you're doing disk I/O. And so it's not very efficient on DOS, which is often used on floppies, to actually be hitting the file system all the time like this. It's more efficient if you can read more of the file into memory at one time and then work on what you brought into memory. So let me go ahead and just wipe out what I've got. Here we're going to create a we're going to use a buffer. So we're going to read something into a buffer. And so for that, I'm going to need to have a buffer to work with. So let's go ahead and do a char of a buffer. Let's call it buff. I'll have to make a definition for this, but we'll call it, let's say, buff size, right? That's the size of the buffer. And up here, we'll go ahead and create a define the buff size of being, let's just make it something small so we can kind of see what we're working with. You'll see why I'm doing that here. So there's 8. I'm also going to need to, turns out, track how much I've read in at any one time. So I'm going to need an integer that is the length of something that I've read in. Now I need a while because, of course, I need to work on a file. And what is that? What's inside that while loop? Well, I'm going to let's first of all look at what's inside the while loop, and then we'll fill out the parentheses here in just a second. So I'm going to need to do an fread on a file. So we're going to read a file, and we're going to read it into a buffer. And it's got a couple of different options to fread here. The second one is it needs to know you can use fread to read all kinds of different files. In this case, I need to tell it what's the size of the smallest thing I'm going to be reading in. And in this case, it's the size of a char value. Now this is going to be dealt with at compile time. This is not. It looks like a function. It's not really. And then how big of the buffer am I reading in? It's buff size, right? And where am I getting this from? I'm getting it from the from p file. That's the file that I've got open, right? So when I've done that, it's going to return a value. Oops, it's going to return a value that is how many characters it's read. So that's why I need to store it into a variable called, in this case, len. Now that I've done that, I need to write it out. Now, there are different ways you can write it out. Since we know exactly how many characters we've read in, we can actually use the partner function for fread called fwrite. So we're going to write out to a file. We're going to, what are we writing out? Well, we're writing out the contents of the buffer. And what are we writing out? Well, we're writing out the, again, size of char. That's the smallest unit of the thing. How big is my buffer? Well, in this case, it's however many characters I just read in the fread. So I need to pass it len. And I'm going to print out to a specific file stream, which in this case is the standard output. And that, in this case, would go to the stream. Go to the screen. Now, when does it end? So that's up here back in the while statement. When I can do a test, so as long as I haven't hit, so there's the not, as long as I haven't hit the end of file, FEOF, right, the end of file, in the P file, it'll run this loop. And that turns out to be a much more efficient way to read a file. Now, if you have a larger buffer, that actually will make it even more efficient because it's able to read more of the file at one time, basically hitting the disk less. Let's go ahead and just see what we've got with this. Save, and we'll go ahead and exit. And let's go ahead and recompile my ntype.c. And you can see here it's compiling it, and now it's going to link it, and there we go. So let's do ntype on our test file, And you can see it printed out the file. Now, how do we know what is actually done? Let's add some just a couple of things here. ntype.c. So before and after the write command, the fwrite in our function, I'm going to add something here, just to see, just to show where the buffer is starting, how much I'm actually reading and writing out. So really, just around this fwrite, I'm just going to do a put char on just a single character to indicate the start. In this case, I'll just do it as sort of an open square bracket. And then at the end, after the fwrite, I'm just going to do another put char for a closing bracket. And so you can see what it's going to do here is as it reads through the loop, let me go back up here, as it's reading through the loop until it hits the end of the file, it's going to run the loop and it's going to do an fread. It's going to read the P file into the buffer of however big the buffer is. In this case, it's going to read 8 characters at a time. And then it's going to print them out. But as it prints them out, it's going to put a square bracket before and after that buffer. And so what we're going to see then when we compile this and run it against the test file is we're going to see chunks of the test file surrounded by these brackets. And I'm just doing this. You wouldn't normally put in those brackets, but in this case, I'm just trying to show what it looks like. And so let's go ahead and compile our new ntype command. And there's compiled it, and now it has linked it. And if I do a dir, right, you can see what's in there. And we're going to go ahead and do an ntype on test.txt. And now you can see that it's put in the square brackets. And as you kind of look through that, you'll see that each one of those brackets contains 8 characters. This space is space, that's 8 characters. A space line space O, that's another 8 characters. F space text period, there's the line return, that's another 8 characters. And that's the rest of the file, as you can kind of see. So it's reading blocks of text 8 at a time. And then one more thing, just to show you the efficiency here, edit ntype.c. This is the last change that I'll make. I'm just going to go ahead and set a larger buffer. And you could set this to something like 1024, so you can reading 1K at a time. Actually, let's go ahead and do that. Let's go ahead and set this as 1024. That's a pretty big buffer. I'm going to read 1K at a time. So let's go ahead and save and exit and wcl ntype.c. And now it's compiled. And now it is linking it. And we're going to do ntype on test.txt. It's still going to print those brackets, but in this case, it's reading up to a K of text. This is smaller than a K of text, so it's going to just have brackets on the beginning and the end of the file. And you can see here brackets at the beginning and end of the file. And so that's a simple way to write programs in FreeDOS. I'm just using the OpenWatcom C Compiler. I've just written 3 very simple demo programs. And that's what we've got here for just a simple introduction to programming on FreeDOS. What other topics would you like me to cover in these video series? Leave your ideas in the comments below. And always, as always, join us on Facebook, follow us on Twitter, and consider supporting me on Patreon. Thank you.